Guys, I've been streaming for like 3 minutes, or recording for like 3 minutes. Yes, I was not streaming. But it's okay. I figured it out. So we're good now. Anyway, there we go. Stream notification in the Discord. I was very distracted during those 3 minutes with a random Discord mention. So now I'm not distracted and I don't have to worry about it. Anyway, what we're going to be doing, WGPU, that is a graphics library that like abstracts like Vulkan, Metal, OpenGL, that kind of stuff. And WGSL, that's their shader language, and Winit is a windower. Uh, so the cool thing about WGPU is that it uses Rust and it's cross-platform on web, Windows, Linux, Mac, and mobile, which is I think that's cool. And it uses Rust, and it's written in Rust as far as I can tell. It's not like some C binding weird stuff, even though someone told me on Discord that that doesn't actually matter because of linked object optimization or something like that. Anyway, uh, so I've already gone through this tutorial a little bit. As you can see, we got window.rs. This is the Windows. Yeah, this is where all the code is. And we have shader.wgsl, which, yeah, that's where the shader is. Cool. Um, so the vertex buffer. Previously, so, okay, so I'm on buffers. I've already gone through the vector shader, the fragment shader. I don't know. I I, I like don't understand it. Um, I I I get the vertex one maybe. Uh, it takes in the index of the vertex and then it does some weird stuff to make it a triangle. But I don't know why they want that. So, yeah. Um, and we also have main. That's the fragment shader. And they wanted me in here the challenge. They said make it dependent on the triangle's position data. And uh like I can do that. Like watch this. So here, shoot. Uh you can see I got a brown triangle that's hard coded and floats. But if I do like pose 0, then I get, once it's done compiling, it'll be a different color. And that's cool. I don't know. So, but there are 3 points. You see, there's not just one point. So is it getting the first one or the last one or for some magic the middle one? And why, if it's coloring, I don't know what a fragment is, to be honest. I don't know if it's supposed to color things, color what you're drawing. Um, but I'm only coloring one thing, the the face, the triangle. So I don't know why you need to call this function 3 times, or even if it's even doing that. I don't know. And there's no way to to check other than maybe looking in the documentation, and that's what I'm going to do. I'm going to look in the documentation, WGSL, look in fragment And so, okay, that is not useful at all here. Mm, so it's gonna be, they have these stage things. So if I do like stage fragment, maybe it'll describe it there. Uh, did not. Stage. Entry shader stages. Okay. Processes each fragment, possibly producing a fragment out. So we cannot produce a fragment output? That's a failure. This implies. Well, I don't know what a fragment is. Okay. What is a fragment shader? I did not. Mm. A fragment is a collection of values produced by the rasterizer. The size covered by a fragment is related to the pixel area, but rasterization can produce multiple fragments from the same triangle per pixel. There will be at least one fragment produced for every pixel area covered by the primitive being rastered. So the number of fragments that I have in the triangle is variable, not depending on how many pixels there are, unless the rasterization method does that. So it should be getting called once if everything is the same color based on the vertex I gave it. Cool. Uh, Fragments generated by the raster, maybe discarded. Nice. Alright, what is it? Wait, this is saying something different. A fragment is basically a position on the window XY, a depth value Z, plus all the interpolated data from previous stages. Well, that makes me think it should be outputted as like a rainbow. So, it's obviously not that, right? The fragments that were found by the restoration of this are now fed one by one. The shader is not optional unless transform feedback is being used. Fragment shaders can access the fragment position. So this variable name that I got from the tutorial is maybe not very uh descriptive. Uh Don't worry, I'm too dumb for this too. Uh, my goal is to not be too dumb for this by the time I hit the end. Uh, why, quiz, wait, neither at the, wait, switch the scene. Alright, and then the fragment shader only has access to the current pixel. I don't know what that means. Anyway, this doesn't seem to be the right, what? So I want to change how the fragments are being broken up. Based, oh wait, oh this isn't Wikipedia, it's a OpenGL wiki. Okay. So where does it say what multi-sampling parameters? So if I go here, did I assign multi-sampling parameters? I think that would be in, I'm not sure where it would be. It's not in, oh, multi-sample. Oh, yo. Wait, so if we bump this to 3, it crashes. That's great. uh, I was so excited. That's unfortunate. So multi-sample state. It describes the multi-sampling state of the pipe. Number of samples calculated per pixel for anti-aliasing. For non-multi-sample textures, this should be okay. Why? Well, I know why they gave me the option, but why is this one not even on the latest version? Come on. Oh, what the? Okay, I understand why it's not in the latest version. I'm not mad anymore. Looks the samples of a pixel modified by this pipeline. Those words make no sense to me. I know what a bit mask is. I guess samples. So, okay. I think I get what that means. Like it's like a limiter for the count. I don't know. I think maybe that's for like you want some things to render and other things to not based on their mask value. I have no idea how you'd set a mask value. And yeah, I don't understand. Nope. Multi-sampling produce multiple fragments per triangle. Okay. Ah, okay. Multi. There might also be something in here. Multi-sampling. Sample. So, what are these keywords? Nice. So, there's multi-sampling. We know there is multi-sampling. How do I make it do different thingies? Multi-sample texture. So this documentation, the whole specification is like not finished at all. So none of this, it doesn't really matter. Yeah, nothing makes sense. It doesn't have to, it's not required. I don't think there's gonna be anything in here. What returns? Uh, instead of mentions. Okay. So maybe only textures can be multi-sampled or something. I don't know. Anyway, that's all they got on multi-sampling. So people don't seem to be using multi-sampling for creating like rainbow triangles, which I don't know, maybe they're missing out, but I know what a super sampling is. That's I don't know if that's the same definition. It's when you got small image and you make a big image with AI and it doesn't look as bad as if you just did by cubic scaling or something. The only change is not executed per sample. Exactly how frequently it gets executed. I want to make sure. So this does still crash. Oh wait, I add the C to the thing. So this doesn't crash with one, right? This compiling thing. Yes, it doesn't crash with one. That's so cool. What if I set it to like another even number? It shouldn't crash, right? Or it should still crash. Yes. One and two. One's odd. So anyway, I've tried one, two, and three. Only one works. So I can't. I know I can't just bump that number. Oh. These people are insane. I think this isn't what I want. I don't think. What's a depth stencil? Maybe, okay, after I look at depth stencil, I'm gonna look at that topology parameter. So what is it? So that's part of render pipeline descriptor. This is just because I see. So it's at the none, but would this be what I want? I don't think it would be. Okay, that's cool. Describes. Oh, the effect of draw cause. I don't think that. Yeah, not what I want. Uh, okay. So what is topology? The primitive topology is to interpret vertices. So I got a triangle list. Oh, okay. So I was wondering about that earlier. So you got like a buffer of your vertices. It's like, how do you know what? Because you got to make triangles out of all of them. So how do you know? I don't know. But you got a list of triangles. But that's kind of dumb because if you got things sharing vertices, a triangle vertex data is a triangle strip. Each set of three adjacent vertices form a triangle. What? One, two, three, four, five creates four triangles. But then how do you make a triangle not connected? That's why they do triangle lists. That's so cool. Um, so would I be able to make I assume I'd be able to make a render pipeline, like multiple render pipelines, maybe? So then I'd be able to make things not connected. Well, I guess you could, with a triangle strip, make triangles that are invisible, and then you'd want to kill yourself trying to figure out how to generate those lines. Uh, but you could, and you'd save data going into the vertex buffer. You can't see a line unless, like, you give it thickness. Is that what they're doing? Yeah, I assume that's what they're doing, right? Unless they're dumb. OpenGL has a lot of thingies. Uh, well, is this even OpenGL? It's from Microsoft. What's Microsoft's thingy? I know they got a thing. I don't remember what it's called. Xamarin? No shot Xamarin has its own graphics library. Oh, it's OpenGL. Okay, yeah. I mean, this is cool. Got lines, we got points. I can't imagine someone using points. Unless, no, because that's for generating with fragments. Oh, oh, yeah, okay. And I just kind of want to look at the render pipeline descriptor so I can, just the whole thing. The layout of bind groups for this pipeline. So we have render pipeline layout up here. So it's got a name. It's got bind group layouts, whatever that is. Okay. Uh, I guess I can open a tab for that. The compiled vertex stage, got that one. Primitive, depth sensor, multisample, fragment. Okay. The properties of the pipeline at the primitive assembly and rasterization level. If set to true, the primitives are rendered with conservative overestimation. Any rasterized pixel touched by it is filled only valid. Uh, I don't know what that implies. I assume it's faster. I don't know if that makes it less accurate or because the triangle's already filled. So uh, yeah, well, it would be filled by this. Yeah, yeah. Okay, cool. Pipeline layout. Wow, that is not useful at all. Oh, pipeline layout descriptor. Okay. So does this automatically? Oh wait, oh there. Bind group. Yep. Push set of push constant radius. That's. I feel enlightened. Okay, let's go. Oh shoot, go back. I'm enlightened now. I understand this. Maybe. What is this tab? Why do I have this open? What is ROCS? Ah, it's a list of asked. I think I opened this earlier. Like they pointed at a thing. Okay. So I'm not doing the pipeline challenge because the pipeline challenge is dumb. I already kind of did it and they want me to make it change if I press like space or something. I don't remember. Anyway, we're gonna go to buffers. Buffer is a blob of data. Blob is an array because apparently it's too hard to say array. Or array of binary. A file, basically, in memory. A buffer is guaranteed to be contiguous, meaning that all data is stored sequentially. Yes, it would be implied if they just said array, but it's cool. Uh, but it can store more complex stuff such as graph structures like trees. We are going to use buffers a lot. Yes, I understand. So they want us to create our own struct for vertexes, or vertices, whatever plurality you want. And yeah. So I already Googled what the recurc thing is. It changes how the struct is saved in data or memory to be like C instead of Rust. Uh, I think I closed that window though. Anyway, so we got position and we got color because each vertex needs a position and a color. Even though there can only be one color for the whole triangle, so I'm not sure. Yeah, I don't know why. Anyway, so let's pop the const vertices. Whoops. And then so they're arranged counterclockwise because we said that here counterclockwise. Yeah. And that also determines the normal of the face. So even though this is already a buffer, Um, they want us to make it more of a buffer, which I think is dumb and a waste of computation time. But I don't know how else to do it, so I'm gonna listen to them. Uh, and we can add that to the new function in our state. And just pop it at the bottom. Let vertex underscore buffer equal what I'm about to copy from this website. There we go. So they have this byte muck crate. I don't know what byte muck is. Small tilde is for casting between plain data types. Huh? This crate is core only by default, but if you're using I don't know what that means. So using your own types, if you're very sure that your type is eligible, you can implement those traits for your type and have full casting support. However, these traits are unsafe. You should carefully read the requirements before adding them to your own types. Cool. So I do want to know what this means, plain old data. Listen, what is non-plain data? You can really go to town with the bit fiddling, a bit casting, therefore it's a relatively strong claim to make about a type. You know, okay. So it's not a class. Right? The type must be inhabited, no infallible. Not sure. I'm not completely sure that this vertex thing is infallible, actually. So, the type must not allow any bit pattern, no bool or char. What? What is an illegal bit pattern? If it's something like you have an end of file thing in your binary blob, that is ridiculous. Uh, uh, where was the thing that I was reading? Okay. Uh, is 4 bits to represent a single digit? These people, what? Who? Why? Why would? Huh? S- Why would they do that? They already got to convert it to binary, right? Oh well, it's not my problem. Not my problem. Anyway, I don't think that's what I'm trying to figure out. I don't know what an illegal bit pattern is. I'm never gonna know. The type must not contain any padding bytes, either in the middle or on the end. I keep hitting my headset. I'm sorry for that. I also know repr C stroke, which has. So how do I know it has padding on the end or not? Needs to have all fields also be pod. Type needs to be repr C or repr transparent. In case repr C, the packed and line repr modifiers can be used as long as all other rules end up being followed. Why would it have why do either of these have padding? So U8, U16 has padding in the middle, but why? Why would it have padding in the middle? Uh, how to determine if struct has padding? Oh, wait, no. I understand. I understand. Maybe. Hold on. Let me look at this for text any. I think I understand. Maybe. But it would be stupid. So here, I don't think this is what I'm looking for. Oh, so these are people trying to detect it. I just kind of want, okay. Why would a struct be padded? So I don't know if this is a C thing. Okay, so it's when I think I get it. So it's when but no, that didn't make any sense. Maybe I should watch this video. It is using C like structs, so like here, I'm just gonna read this Stack Overflow thing. Sizes of the structures are 12 and 8 respectively. Are these structures padded or packed? Uh, Padding line structure members to natural address boundaries. Say int members would have offsets which are mod 4 equals 0 on 32-bit platform. Padding is on by default. Insert the following gaps into your first structure. Insert by packing on the other hand prevents compilers from doing padding. This has to be explicitly requested. Okay, nice. So bytes are always 8. but CPUs are based on, like, their instruction set is always a certain number of bytes. Like, so they have instructions. The instructions are numbers, and the numbers are sequential. So a 32-bit processor, which is a 4-byte processor, reads each instruction 4 bytes long, even though it could read it byte by byte. So what I think this means is that because where is this? So this number is 2 bytes long. This number is 1 byte long. So this is the total struct size is 24 bytes at the smallest. But to make it easier to process, it makes both of these 2 bytes long to get a 32 or a 4-byte struct for memory. But why? Because 16, it would still be hard on the processor, right? Because what is a no padding? Well, I guess this is a no padding example. I got no clue. I don't know. I don't know. Um, Gosh. Okay.
In this presentation, we'll try to understand the concept of structure padding in C. So let's get started. How memory is allocated to structure members? That's a very important question. When an object of some structure type is declared, then some contiguous block of memory will be allocated to structure members. So when an object of some structure type is declared, then the contiguous block of memory has been allocated for the structure members. For example, if we have a struct ABC which consists of 3 members, 2 are character variables, 1 is an integer variable, then a contiguous block of memory will be allocated to these members. First, the memory will be allocated to this character, then this integer.
Okay. I was hoping I would be able to understand them at 2 times speed, but I cannot.
2 are character variables, 1 is an integer variable, then a contiguous block of memory will be allocated to these members. The contiguous block of memory has been allocated for the structure members. For example, if we have a struct ABC which consists of 3 members, 2 are character variables, 1 is an integer variable, then a contiguous block of memory will be allocated to these members. First, the memory will be allocated to this character, then this integer. Okay, and we can see here this is the object of this structure type, right? So when after creating the object of this structure type, the memory will be allocated to them. Okay. Now what is the size of struct ABC? That's the question of concern. Let the size of integer is 4 bytes and size of character is 1 byte. I'm assuming here that the size of integer is 4 bytes and size of character is 1 byte. Then in that case, this character will get 1 byte, this character will get 1 byte, and this integer will get 4 bytes of memory, right? Total will be 6 bytes. Isn't that so? But let me tell you that this is wrong.
Oh no.
You are wrong here. There is a concept called structure padding which we have to understand here. Processor doesn't read 1 byte at a time from memory. This is very important for us to understand that processor doesn't read 1 byte at a time.
Unless it's an 8-bit processor.
It reads 1 word at a time. Now what does this mean? What is the meaning of this 1 word? If we have a 32-bit processor, then it means it can access 4 bytes at a time, which means word size is 4 bytes. If we have a 32-bit processor, then it means it can access 4 bytes at a time. Instead of accessing 1 byte at a time, it can access 4 bytes at a time, right?
Wow.
And if we have a 64-bit processor, then it means it can access 8 bytes at a time, which means word size is 8 bytes.
That's so
Try
cool,
to understand
man.
the meaning of this 32-bit and 64-bit here. 32-bit processor means the processor is capable to access 4 bytes at a time, okay? And 64-bit means that processor is capable of accessing 8 bytes at a time, okay? So it is not the case that processor reads 1 byte at a time from memory. It reads 1 word at a time. Now it depends upon the architecture that what is going to be the size of the word. Okay.
Okay,
Now here in this case,
understandable.
memory is allocated like this. First the character A will get the memory, then character B, and then the integer C, right? This is how it gets the memory, as contiguous
Correct.
block of memory has to be allocated. Therefore 1 byte for character A, 1 byte for character B, and 4 bytes for integer C, right?
Just
What's the problem here?
the problem
The
is
problem
that
is that in
CPU
one CPU
cycle.
cycle,
It's too
character
many
A,
cycles,
character
man.
B, and 2 bytes of
Oh,
integer C can be accessed, right?
yeah.
This means that
So
in
why
one
aren't
CPU
these U
cycle, 1 word can be
size
accessed, right?
or F
If I'm
size?
considering 32-bit architecture, then word size will be 4 bytes, right? This means that in one CPU cycle, 4 bytes can be accessed. So,
Yes.
character A, character B, and 2 bytes of integer C can be accessed at a time
Yeah,
in
they
one CPU
can.
cycle, right? And there is no problem with character A and character B. In one CPU cycle, both the variables can be accessed easily. There is no problem with it. But whenever we want the value stored in variable C, 2 cycles are required to access the contents of variable C. Here in this case, suppose we want to access this variable only, right? Then 1 cycle is required to access these 2 bytes, and 1 cycle is required to access these 2 bytes. So total 2 cycles are required to
So it
access
can
this
read
variable C.
one word.
Isn't that so?
Ouch, my
In first
finger.
cycle only we would be able to access
Anyway,
first 2 bytes, right? While in the second cycle the last 2 bytes.
so it can read
Because in one
one
cycle these 4
word.
bytes can be accessed, and in the next cycle rest of the 4 bytes can be accessed. In the first
So
cycle we would
16.
be able to
I
access these 2
understand.
bytes only, and in the second cycle we would be able to access these 2 bytes. This is the problem.
Maybe.
Unnecessary wastage of CPU cycles exist in this case. Here, in order to access this
Stupid
variable,
CPU
2 CPU
cycles.
cycles get wasted, right? The scenario is like this only, that suppose we just want to access this variable. We are not interested in these two variables. Then 2 CPU cycles are required to access this variable, right? Which is an
Yes.
unnecessary wastage of CPU cycles. We can access
Don't
this
you
variable in
waste my.
one CPU
We've
cycle as
already
well,
gone
as the
over this,
size is 4
man.
bytes, right? So in one CPU cycle, we can also access this variable, but unnecessary 2 CPU cycles are required to access this variable. This is not correct. That is why the concept of padding came into picture. We can save the number of cycles by using the concept called padding. Okay.
Oh, I love
Here, we
padding.
created an empty room, right? Why this empty room is created? Because we understood that variable C is overlapping here. 2 bytes will be allocated for the variable C here and 2 bytes here. Because of the concept of padding, empty rooms will be created here and variable C will be allocated in this memory location. Which means that variable C will get these 4 memory blocks. With the help of padding, variable C can be accessed in one cycle. Although memory is getting wasted, but variable C can be accessed in one CPU cycle, right? So total number of bytes allocated in this case will be 1 byte for this character A, 1 byte for character B, 2 bytes empty room,
So,
and 4 bytes for integer C. Total number of bytes are 8. Therefore,
if I could just.
the output of this program is 8. But what happens if we change the order of members? Does it affect the size if we change the order of members?
No, because the
Here in this
compiler ain't
case,
that
we
dumb. Come
change the
on,
order
right?
of members. Here
Please.
we have character A, then integer
Be
B,
smart.
then character C.
Be smart about this
Integer is in
compiler.
between these two characters. Does it affect the size? Let me tell you, the output of this program is 12. I mean, from 8 bytes, it changes to 12 bytes. In the previous program, we got 8 bytes. In that case also, we have 2 characters and
I
1
can't believe
integer.
this.
In this case also, we have 2 characters and 1 integer. Why we are getting this output 12? Let's try to understand this properly. Here,
Compiler.
the character
No
A will
way.
get
No
this
way you're
block
this
of
dumb.
memory. Then after
Uh,
that, this integer B has to be allocated. But this variable will not get these 3 locations. Why is that so? Because if we get these 3 locations, again the memory cycle will get wasted, right? In that case, if we want to access this
there's no
variable,
way compiler's that
then
dumb.
one
I
cycle is
refuse to
required
believe
to
it.
access these 3 bytes and one cycle is required to access the last byte
Oh,
of
but
this
I can
integer.
figure out a
Therefore,
reason
integer
why it'd
B
be
will
that
not get
dumb.
these
Oh
locations,
no.
right? Hence,
No,
these
compiler, maybe
rooms
you're
will
right.
remain empty. These locations.
Serialization,
Now what happens
maybe.
to character C? character C
He's
will
so
get this
sad.
location. But one important point we should understand is that at a time, one word will be accessed. In first CPU cycle, processor will access this, which means integer will get access to this is just architecture. Okay friends, hence the output of this program is 12.
That's
Okay?
so sad. That's so sad. I can't believe this. What I'm trying to think of words right now. It's not a compiler. No, no one questioned the compiler. Someone please, compiler. Word size depending on CPU. But when I use 16-bit compiler, it's giving to. Yeah, no. Of course. How is he using a 16-bit compiler on it? Why does he got a 32-bit processor? And his system? Huh? Maybe they're on a Raspberry Pi or something. I don't know. Weird. Compiling to RISC-V. Uh, anyway. But if you're compiling to RISC-V, you should know what the padding thing is, right? Anyway, well, I guess that's why they're going over it. Never mind. Anyway, so this this thing is still confusing. Where are you supposed to have padding? You need padding somewhere. I mean, you can just disable padding, so it's okay. It's okay. Did this disable padding? It didn't. So, if you compiled this on like a 128-bit processor, it might not handle it well. I don't know. Anyway, I have to go to the bathroom, so I'll be right back. I've returned. Uh, all right. So, we're back. Nice, cool, great, awesome. So yeah, still doesn't make any sense to me. Maybe can maybe charge R1 byte and see. Huh? You heard nothing. Prohibition of allowance work. We're not gonna deal with it. Hierarchist Fragment, I'm so glad you're talking about this. Can't right now. So doesn't make any sense to me. Still, if you can't, if you can't have, why can't it have any padding? That's dumb. So when something is marked as penalty, okay. So okay, maybe one day it'll click. Is that what version it's on? It's on 1.7 now. That's cool. Big ups. Okay, so let's go back. We have vertex buffer. No method named create buffer in it. Oh, why? So, well, tell me. Come on, Crash. Tell me the thing. Oh wait, I need to add vertex underscore buffer here. Uh, trait pod is not implemented for vertex. Yep, unfortunate. So I have to add a WGPU. This scrolling thing kinda sucks. Oh, okay. So device extensions. Is that what that is? I don't care to check. Anyway, util st. Yep. Uh, device ext, comma. There we go. Now we do no, scroll back up. We had so yeah. Zero will indicate that we can use map zeroed. Okay. So why struggling with this type of okay. I don't would I why would I need that? I trust it. Pod, byte, muck, colon, zeroable is nothing is. Last time I checked, WGP doesn't re-export anything, so no re-exporting for me. I need to blow my nose. Okay, nice. Scroll. There it is, vertex buffer. So it's got a label, it's got its contents, and it's got its usage. Ooh, what are the other things it can be used for? Why doesn't this? Huh, I can do that. Why is it so hard to find? What is it? Buffer. I can. Ah, shoot. I can find it myself. Watch this. Buffer usage. Oh, never mind. Shh. Why did none of these? What? Why is? Huh? Okay. Whatever. So what do I do with it? We need to tell the render pipeline to use this buffer when we are drawing. But first, you need to tell the render pipeline how to read the buffer. We do this using vertex buffer layouts and the vertex buffer fields that I promised we talk about when we created the render pipeline. Guess they promised. A vertex buffer layout defines how a buffer is laid out in memory. Without this, the render pipeline has no idea how to map the buffer in the shader. Here's what the descriptor for a buffer full of vertex yep, would look like. That's more than I thought it would look like. Oh, okay. So we got vertex buffer layout, rate underscore strat as human size of. Oh, wow. Oh, so that's why there can't be any padding. Okay. If only they would have. Shoot, sorry. If only they would have said that. That would have been so nice. If they say, like, oh, it needs to be plain old data with padding, doesn't. Wow, that would have been so sick if they explained it. Man, oh. So it has nothing to do with the. Well, maybe it does. Oh no. Oh no. Depends how wide a vertex is when the shader goes to the level. Okay, so it'll be probably? Oh no. Wait, how would it? Wait. Hmm. Vertex, because the vertex, it's eight or it's four bytes per point. Not 3 points. Can't. It doesn't make any sense. Stupid. Uh, also zero. So step modes tells the pipeline how often it should move to the next vertex. This seems redundant. In our case, we can specify instance. Only with the changed vertices when drawing a new instance. Huh? Oh, I understand. So it's oh, when you're doing multiple instances, you don't have to go over each vertex multiple times and go through all the vertexes once and then just move the instances. Whoa, that's so genius. So you can't change. You have to update the vertex. Where does the vertex buffer go? They'll say that later, right? Uh, why does that? What? Why does that have a lifetime parameter? Okay, they kind of just attributes. Describe the individual parts of the vertex. Generally, this is a one-to-one mapping with the struct's fields, which is our case. Vertex attribute float 32x3. I understand that. I'm trying to fit this into why there can't be any padding. Who says there can't be any padding? The ver... The buffer makey thingy can't no pad. It can detect there's no padding though, right? So I just gotta use my little noggin, right? No, maybe. Well, it makes it unsafe if because the padding varies. So you have to use packed. So why doesn't this tutorial use packed? Because then you get memory leaks, right? Okay. So I'm gonna figure out how to make it how I'm forced it to be packed. Where this is this at all what I'm looking for? Pack struct. Okay. Lowered. Does how how do they know what how packed it is already? It doesn't matter. It doesn't matter. Well, it's sick. Okay. Okay. So they have uh so I'm gonna copy that. So this you have to describe what the vector the vertex what wait why would you do it there? Anyway, I'm gonna remove this lifetime parameter and see what it does because I don't understand why you need it unless it does need it. Why do you need it? Because attributes oh it's a slice. Yeah, okay. Understandable. Okay. So this. So number five. What's number five? Shader location. This tells shader what location to store this attribute at. And fact3x and the shader would correspond to the position. Okay. Yeah. Why would it? Yeah. Uh, why wait? Why is this an unsafe rest? This may improve, but may have negative side effects from field access is heavily penalized to completely breaks everything based on target platform. Will, not may. Yeah. Man, this GPU stuff is wacky. That's not what they say, though. Okay, yeah, it's cool. It's cool. Okay, starting with no vertex that returns this descriptor. Yes. System attributes, as we did now, is quite verbose. We could use the vertex attr array macro provided by WGPU to clean things up a bit. With it, our vertex buffer layout becomes this. Yeah, yeah, I'll do that. Yeah, that sounds like fun. WGPU vertex on still can't spell underscore editor array exclamation point 0 arrow comma 1 arrow float 32x3 and float 32x3. And we got our thingy here, and it's got a big error, cannot return value referencing tab referencing cannot return value referencing temporary value. Where temporary value occurred here at 18. Oh, wait. Oh, macro.rs. Hoffman's vertex. Wait, oh, no, it's not. It's turns it. Why is this so temporary? Oh, you don't need it there. Then, and you need to do this and static, right? Move bar expressions cannot be annotated. So then, like that, and it's still gonna cry about it. So I mean, so I don't understand. It could just be static. Well, oh, if I try to compile it, what it do? Nah, it tries. It's gonna be temporary. Then fine. If you want to be like that, it don't work still. Yeah, of course it don't work still. So no macro? So if you can't use the macro like that, then I don't know the point. Won't go back. There's nothing here that why this can't change. I'm ignoring that for now. Doesn't matter. And then we can use it when we create the render pipeline. Oh, you put it. Oh, so render pipeline. Here it is. Vertex state buffers. What? Vert descriptor. One more thing, we need to actually set the vertex buffer in the render method, otherwise our program will crash. Whoops. Understand. Oh, these words are so awesome. Okay, so we hop down to our render thingy, and here we got uh so we got the vertex buffer described earlier, and then the index, right? Slots, close enough. Buffer slice, put the slice in there. Blam, and then we don't need that. Then it draws 0 to 3. Oh, whoops, I don't know where I am now. Anyway, 0 to 3, 0 to 1. Oh, never instances. Okay. Why does it gotta be? Maybe it's easier to compute with range. Anyway, so we should get a triangle. Triangle! Oh, well, we didn't change the shader at all, so I actually pretty should. How bad we messed that up? We should be getting a triangle. So, okay. So slice allows us to specify which portion of the buffer we use. We use dot dot to specify the entire buffer. Before we continue, we should change the render path dot draw call to use number of vertices specified by vertices. Yes. That num underscore vertices colon u32 and sick. And then we hop down here, vertices dot len as u32. Apparently, because we can't use usize, that's too hard. Right? Is that because is the range typed? It won't let me check anymore. Vertices.len. Oh, it's fine. Now let's assign it to a variable first. Num underscore vertices equals that's num underscore vertices. Oh, that might have been a different issue, but anyway, oh shoot, vertices. That's how you spell it, man. Huh. How days? Vertices. Has it always been spelled like that? Or is this tutorial spelled like that? Vertices. Oh my god. It's always been spelled like that. Vertices. Whoa. Okay, well. Lesson learned. And then do it in the draw call. Come on. Give me this draw call, render self dot num vertices. Cool. For our changes will have an effect, we need to update our vertex shader to get its data from the vertex buffer. We'll also have to have it include the vertex color as well. Yes. Understand. Uh, but I thought I need to go through all that. It's like, hmm, it's okay. It's okay. It's fine. Wait. Oh, oh my God. That's why it said, whoa. So the rest, so the input for the fragment comes directly from the vertex shader. That's, this says it say that in here, and I just didn't. This one takes none, so I should have. What? Gosh, I'm so stupid. What? They're kind of. This didn't really help here, but shoot. So they just call it in. Statements, functions, function calls. Statement, yeah, that's nice. Um, function for user fields and W, no aliasing is present in any combination of yeah. Shader stage. Oh, this isn't even done. Well, what helps? A pipeline input is limited by the arguments of the entry point. Wait. So if I go to fragment shader entry point, targets, format, no, this doesn't declare its inputs. So never mind. Um. Anyway, that's amazing. Uh. So I guess. How does it know? I don't know. Oh, how does it know? So if we're outputting our own, I thought it had to be a vec4. Well, oh, that's why we say built-in position. Oh, whoa, whoa, whoa. Oh my gosh. And then each one has a location. So that's custom memory stuff. Whoa. So it push it pushes all the thingies to B1. This is wacky. So the rasterization. Then it knows that there are differences. So then it does the color in different spots. because the vertex outputs are not exactly the same. Whoa, okay, that's cool stuff. So it's like gradients, but magic. So it does gradients by magic. Whoa, who allowed it to do magic? Man, if I wanted these gradients a long time ago when I was doing stuff in P5JS, if I could have just gotten the gradient by telling the renderer thingy to do something, I would have been sick. Oh, that's just different. So it blends. It's the blend mode. Is that the blend mode? Oh, please tell me that's the blend mode. So where's the blend mode? Blend. Some blend state replace. Color. Yeah, that didn't make as much sense as I hoped, but maybe it still does. Ooh, new tab. Okay, blend or color target state describes the color of a render pipeline. The blending that is used for this pipeline. So blend state, that doesn't help at all, huh? Replace blend mode that does no color blending, just overrides the output with the contents of the shader. Yeah, that's not what I was thinking at all. Okay. Alright. So I need to do something else. Something. I need to copy and paste this code. And there it is. And we should get our magic triangle. Come on, magic triangle. Magic triangle. Magic triangle. Whoa. Okay, so we can move our triangle like that and like that. And the gradient moves with it automatically. And then I can squeeze the triangle and wow, it makes a line from blue to red. Why blue to red? I don't even know. Squeeze. Anyway, doesn't matter. We got a gradient triangle. No one's gonna make their window this tiny. That's stupid. Sick. Done everything correctly. And that is the output I received. Now they want to do index buffers. An index buffer comes into play when we start using models with a lot of triangles. Oh no. There is a total of 5 vertices and 3 triangles. If we wanted to display something like this, we just use vertices. Using just vertices, you do the following. You need six vertex. That's a pentagon. They're describing each triangle. Yeah. But that's so lame. C and B is used times and E is repeated 3 times. Assuming this float, that means 260. 96 of them are duplicate data. Wouldn't it be nice if we could just list these vertices once? That's what I was thinking. We can't. Basically, you store all the unique vertices and vertices. Amazing. We create another buffer that stores indices to elements of vertices to create the triangles. Here's an example of that with our pentagon. Oh, I understand. Whoa. If only, huh? Gosh, I should have just kept reading. I wouldn't have to be thinking about stupid stuff. This- Alright, let's copy and paste this code. Go. Padding? Padding. What? Stop. Was it? Now, with this setup of vertices takes up 120 bytes, and indices is just 18 bytes. And that U16 is 2 bytes wide. We add buffering, 2 bytes padding, as WGPU requires buffers to be aligned to 4 bytes. This would have been so great to know before when I was considering ending it all. Um, uh, okay. 82 bytes, all gone. When dealing with try counts to hundreds and thousands. Saves lots of memory. That's what I was thinking. I was like, oh, wasting so much memory. Except now we got these indices. That's so sick. There's a couple of things we need to change in order to use indexing. The first is we need to create a buffer to store the indices. In states new method to create index buffer. After you create the vertex buffer, also change num vertices, num indices instead of equal to indices.lan. Even though I think this will still be more efficient to describe with a triangle. What was that called again? Uh, what is happening? Here we go. Where was it? Uh, topology, triangle, something different. It was like triangle strip. I think it'd be more efficient to do with a triangle strip. I think, though, maybe this should allow you to do multiple models as well. That'd be sick too. Yeah, that'd be sick. So the vertex still has color. So if we got multiple colors, it's weird stuff. Okay, it's gonna be purple. It's so lame. I don't want it to be purple. I want it to be some cool color. Oh, I'll make it a cool color. Don't worry. There's a couple of things we need to change in order to use indexing. So the first, we need to create a buffer to store the indices in states. New method create the index buffer. Okay, let index underscore buffer equals this copy and paste. Oh, it's so nice. And I'm actually gonna move this back up and then copy and paste this and move this. And there we go, copy and paste. That's so good. We don't need to implement pod and zeroable for our indices because ByteMuck has already implemented it for basic types such as U16. So we can just add index buffer and num indices to the state struct. Yeah. Oh, I hope it already added basic types. Oh, okay. Scroll back and then copy this. And this is going to be index buffer. And whoa. Uh, back up. Num indices. How do I spell that? Oh my. It's like I before E except after C or something. I just kill it. Just kill it. So sad. And then populate it in the constructor. Come on, constructor. No. Index underscore buffer. Num underscore indices. There we go. And now what we do is update the render method to use the buffer. Cool. I don't want their comments. There we go. Copy one by one. Everyone gets flashbanged every time I switch. The method name is setIndexBuffer, not setIndexBuffers. Dumb. When using an index buffer, you need to use draw indexed. The draw method ignores the index buffer. Also, make sure you use number of indices, indices, not vertices, as your model will either draw wrong or the method will panic. Okay, so then our num vertices is unused. That's so sad. So what are the what? How did I do that? Okay. Uh, so base vertex. That doesn't make any sense still. Base vertex, the index of the first vertex that you draw. Okay. Uh, I don't know why you'd want anything other. Anyway, see, we got a pentagon. Come on, pentagon. Pentagon! And this pentagon isn't even like straight. It's like at an angle. Yeah, it's wacky. Scroll up. So they make it. It's not at an angle? My eyes are at an angle. Well, I mean, they draw it like it's at an angle, so it's not my fault. It's not my fault. Uh, his people are talking like, oh no, color correction, don't actually care. Create a more complex shape and more on three triangles. Using a vertex buffer and X buffer. Toggle. Okay. I don't need to do the challenge. I wanna color it. So this into C, so it's left. Actually, I'm just gonna pull this up. So the center point is in the middle because the people who made this are psychopaths. Uh, so negative 0.8. That's the top one, I think. And then 0.5. Yeah, that's the top one. Then it goes that one. Oh no, then goes that one. And then it goes that one. So it's kind of clockwise. Yeah. And that one. And then that one. Cool. So let's say I'm gonna make a gradient from like blue to white. Uh, so RGB blue. So top one is gonna be 1 and 0. And then I kind of want the corners. What do corners be? Corners could be green. Yeah. Okay, I have to do decimals because it's floats. Uh, Corners are green. Wait? Oh, never mind. I'm going crazy. So that's a corner. That should be the left one. We got two bottom ones. The bottom one's gonna be white. So 1.0. And then this is another corner. It's gonna be 1.0. And then all on 0. And oh wait. Oh no, this one is not. This is the second bottom one. Sorry. Then this is the second corner. So 1.0. then 1, 0. And we should get a pentagon with wacky stuff. Wow. So, that's not what I meant to do, because green, RG, yeah. So here, let me fix that. Wait, uh, fix that here. RGB, G in the middle. So this should give us what I was kind of thinking of. So this also shows us how. So, huh. This, maybe it's based on how the triangle is cut up. That'd be dumb. But I think that's how it is. Because it's really green here, and it should be kinda similar on both sides. Not at all. Though this does come down flat, the blue. But maybe that's just because this triangle is mostly flat. Goes out a line. I don't know. I don't know. Anyway, we got a cool pentagon. And we finished buffers and indices. We didn't do the challenge how they wanted us to do the challenge, but I feel challenged enough. So, it's cool enough. You can load an image from a file? I mean, of course you can, but like, that's wacky. Whoa, the mag filter, min filter, mirrored P. Whoa. So, I guess your shader shouldn't get too big. So that's why you kind of load them in to be compiled. But I guess you wouldn't load images in because then 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 your executable gets really large. And I think executables are fully loaded into memory. Uh, because if they weren't, then that'd be wacky. And I'm sure the programmers wouldn't like that. Um, so I'm not gonna go through this today. Today's done. This all the thinking I'm gonna do today. Uh, so yeah, I'm gonna go to my to-do. There we go, completed. That's sick. Uh, goodbye.